operational plant manager trying to utilize this enterprise generative AI application. So what he really wants is he wants to understand the big volume of IoT data generated from the industrial plants. And however, in the past, the OT team always need to create summaries by themselves or the report by themselves. And to understand the data, it also takes them quite some time to utilize human inference to understand that part. So the question is, how can generative AI help in this aspect? So now it's a demo time. I'm going to hand it over to Sutish.
Thanks, Julia. Okay, so before we get started, let me try to contextualize this and make sure that this isn't part of a story or a journey, right? So the first part is you're going to have a line manager or an operations team member who's getting those insights, and then how does he propagate that into his supervisor? And then how do we make it very, very intentional to tie it back to your relevant enterprise corpus of data to drive some of those insights? So here, this is a very simple front-end UI, right? So if you look at it on the left-hand side, we've added auto prompts to consider where you can specify the number of questions, the number of auto prompts you want the model to generate. We've given the options to create a foundational model. Right now we're using, we're calling this Anthropic Draw through an API from Amazon Bedrock. So the other things here, you have an option to select an output language where most of the alpha and beta quadrant languages are supported. You can just drill down on the specific box and get multiple options for your output. So let's go ahead and select a file which is coming in from the IoT sensor outputs. So I'm going to upload it, and while this is working in the background, let's just quickly look at the data file itself, right? So if you look through the data, let me make it a little more bigger. Okay, great. So here, if you look at it, it's got around close to 50,000 records. Again, this is completely scrubbed data. It's got a site display name, right, across different plants, what the different assets are. And then it gives the sensor position display name, what kind of different industrial equipments are there in the specific industrial line. And then we monitor 3 different parameters. We're doing the temperature, we're doing the acceleration, we're doing the velocity. And then we calculate the temperature machine learning output, whether it's healthy, it's warning, or critical, and also the vibration. Right? So this is the entire data set which comes from the line. Let's assume that. So now I've uploaded the specific line, and then the model goes through and parses through all of this information and generates a summary. So here, based on this specific data set, I want to be very intentional in terms of contextualizing what my top 5 auto prompts should be, right? If it's a specific industrial equipment, and you know if it's a motor or a bearing, you're monitoring the temperature and vibrations, and you find that based on past experiences that temperature increases, something breaks down. Your vibration goes, there's a shutdown of some specific motor or industrial equipment. So this is where we kind of go through the auto prompts, and then it gives you a detailed response, right? Based on the data, there are 19 temperature readings that are labeled as healthy by the ML model, so 0 have a temperature anomaly, right? There are 19 vibration readings, and all 19 are labeled as warning. Let me just, okay. So now you have all of this information, which is fantastic, right? So now a line manager, as I talked about, the persona 1, clearly understands, okay, here is the equipment size, this is a specific part number of this equipment, and then we made it very intentional in terms of, okay, here are the questions which the large language model needs to answer, and you give that. But how is this useful for the next line of chain, right? Let's say you have a supervisor now. Now, what I want to do is now, okay, I have all of those inputs. It gives me different part numbers, different readings, different ratings, and all of that. But let's say that, let's ask, can you summarize this report of the findings? So now, again, based on all of this auto prompts, based on the data set, the large language model will go in and it's it's already set the context on this specific document and this specific order prompt. So the boundary is defined already there. And within the boundary, now I'm going to ask like, okay, how do I summarize the report for the OT manager? So here. So from that entire 50,000 page document, which just had numbers of different temperature readings and sensors and vibration, here's your key summary of the findings from this report, right? So it clearly tells that what does this report contain. It's got vibration monitoring for various assets across the two plants, which is Hobo plant and the Louisburg plant. So it tells us about a few assets which shows vibration levels in an alarm range. Now it tells you that, okay, the large motor site at Hobo plant had high vibration levels on several days. It's just not telling you one specific date. It's just consolidating the entire document, parsing through it and telling you that, okay, based on these different indicators of vibration, here is the result. And then it predicts that this asset may need maintenance, right? So it kind of gives you a summarized view of all of these data contextualized within that auto prompt window, which is really important to call out. Now let me come back to the line manager now, right? So now we talk about, hey, it's 471 VB1 and 3-fan lager motor site. So what does the ingredient thing? It's a critical warning. Now I need to go map that specific part number or that specific industrial equipment into a maintenance manual and understand, okay, here's what the corrective actions which I need to take. But what we have done here is, again, Julia talked about the multimodality. From here, let's say now the line manager has a smartphone. He's using this app. He's just taking a picture of a belt driver, which is in contention with the warnings which have come out. So now we've uploaded that image. The backend Amazon recognition service uses a label detection, and then it's going to drive insights based on the label, exactly telling you which product this is, who is, so usually if you look at a product label, there'll be different, instead of me explaining, I'm going to show it out here. It talks about the image summary, right? This specific image summary, who's the manufacturer, where is it made. There is an electrical diagram here which tells us what thermal protection it would be, and then it gives you a detailed analysis of that specific industrial equipment. Right? So overall, this is an electric motor driving a fan or a blower by a belt and pulley system. The various label identify the manufacturer's product specifications and indicate operating requirements for safe use. So that's how the first two aspects come into, right? You get a report, he uploads it, you get summarized, concise, contextualized outputs based on that specific window of what that document entails in terms of a vibration and temperature reading. And then you have the ability to go in and then select or click a picture of any emission and get insights. Now, what we wanted to do is like take this to the next level, right? Now, we've done this. We want to bring all of this together. So how do we do that? So now you have the report. You've taken a picture of it. Now we want to be very intentional. Again, I say intentional because you want to map it specifically to a product type and a product maintenance manual. Right? If I'm talking about a specific bearing, then that's where the RAG framework comes into the picture, where we try to avoid some of the hallucinations which are caused by these large language models, because they're just vastly trained on huge corpuses of data available. So some of the things we are doing there is, in this case, we use different repositories, right? We talked about Amazon Kendra and Amazon OpenSearch. So Kendra has got different abilities to ingest these files. It also has ability to crawl a specific manufacturer's website, right? Using a sitemap, if there is certain URLs available, you could crawl through that. You could specify with regex patterns that, hey, I want to avoid these pages, I want to include these pages, and formulate your own data set, which can be made searchable, faceted, or sortable within the Kendra space. And then we have the OpenSearch. So OpenSearch is very interesting. You could do, so we launched something called, which is recently announced, which is again in preview, which is the OpenSearch serverless, which has the ability to vectorize the data. So when I say vectorize the data, what it means is that now you have a maintenance manual. You're going to create dimensions and magnitudes. So when you create dimensions and magnitudes,